All right, here we are with part G, intercept form of a quadratic equation. So intercept form, also called factored form, so AKA factored form, and you can see that by looking at it. I see a factored quadratic. The lovely thing about intercept form is that it immediately tells me my roots. So let's go look at this on Desmos. I'm going to make a new graph. New blank graph. All right, so now we've got that our y equals a x minus p times x minus q. Let's add in sliders for all of those. I'm just going to leave my a as 1. But now as I change p and q, notice that my p is 3. I see an x-intercept at 0, 1. I see an x-intercept at, this is 1, 0, x-intercept at 3, 0. This makes me think that if I plot the points p comma 0 and q comma 0, that I've got x-intercepts. Let's play with it a bit. All right, so far so good. So far so good. Notice the minus sign here. So let's just look at this. Let's make these nice numbers. So -2 and 6. This is the same as graphing x minus -2. That's the same as saying x plus 2 and x minus 6. So notice here our p-value was -2. Our q value was 6. Notice if you look at the equation though, I see +2, but the x-intercept is -2. So remember that comes from when I find x-intercepts, what I'm really doing is I'm taking my a and making it, taking my y and making it 0. So a, x minus p, x minus q equals 0. Well, this a is just a constant, it's a number. I can divide it to the other side. X minus p, x minus q equals 0. I'm saying this whole thing, when I multiply, has to be 0 because the only way to multiply and get 0 is if you have a 0. So x minus p has to equal 0, which means x must be equal to p. Opposite sign is what I saw before. So intercept form is really nice because it immediately tells us our intercepts. Let's keep going with this example here. Sketch this graph by factoring. Well, they've given me a huge hint that it does factor. You shouldn't use the quadratic formula. They're telling you it factors. So I'm going to use my box method, my x, 5x up top, -2x squared times 12, -24x squared. I think that's +8x minus 3x, so -2x squared. Putting these two in, that's going to be +8x minus 3x, still the same as the 5x below, plus 12. So we could still say that this is y. When I factor this out, I see that I'm going to be able to pull a -2 from here and get, -2x and get x minus 4. I can pull a -3, also get x minus 4. So this is going to factor, common factor is x minus 4, leaving me with -2x minus 3. I don't like starting this with a negative, so I'm going to factor out the negative from here also. So now I'm going to say -1 in front. X minus 4, 2x minus 3. Of course, I could have pulled out the -2 as well. This would have turned into 3/2. Ooh, that should be +3. It would have turned into 3/2, or I can leave it like this. Just remembering that when I solve this, I need x by itself to get my root. So graph it by factoring. I can see right now, if I set this equal to 0, so x-intercepts at y equals 0, that tells me x is going to be 4, or 2x plus 3 would be 0. That would mean x would be -3/2. Remember, opposite sign is what I saw before. So I can make a quick sketch of this. I know this graph is going to point down because of that negative. I also know my y-intercept is 12. And now I've got 4 over here, -3/2. Well, that's -1.5. That's there. And I can also figure out my axis of symmetry. So I'm going to move over 1.5. That would take me to right here. If I move over, well, I want to find the midpoint of that. The midpoint is going to be 4 minus 3/2. I'm taking the two numbers, dividing them by 2 to find my center. So let's do that. Let's just make sure that's true. 4 minus 1.5, and then divide by 2. 1.25, that makes sense because that would need to be here. So 1.25 is about there. There's my axis of symmetry. So somehow my graph is going to go up and come back down. And so using our roots to help us, and our roots to help us find the axis of symmetry. So that's going to be my x value that's in the middle. And there's how we can use factored form to help us graph.